Nobody is talking about this, but Tesla is not building cars anymore. Not really. They are building something that makes cars look like a side project, and the numbers they just dropped prove it. Let me put this in terms that actually land. Tesla just announced capital expenditures for 2026 that land somewhere between $20 and $25 billion. Not for new models. Not for bigger dealerships. For artificial intelligence, for humanoid robots, for factory retooling, and for computing infrastructure. To put that in perspective, that is roughly the entire annual GDP of a mid-sized American city like Raleigh, North Carolina, being poured into a single year of transformation. And almost none of it is going toward what most people think Tesla actually does. So what is really happening inside this company? Because on the surface, you still see the cars, you still see the superchargers, you still see Elon Musk talking about full self-driving like it is perpetually 6 months away. But underneath all of that, a completely different machine is being assembled, layer by layer, and by the time most people notice it, the architecture will already be locked in. Start with the data. Tesla has somewhere between 6 and 7 million vehicles on roads across the world right now, and every single one of them is a rolling sensor platform. 8 cameras per car, constantly feeding footage of real-world driving conditions back into Tesla's training systems. No other company on the planet has this. Not Google, not Amazon, not any of the traditional automakers. When a Tesla drives through a construction zone in Phoenix at 2 in the morning in the rain, that moment gets logged, processed, and used to make the model smarter. Multiply that by millions of cars, billions of miles, and years of continuous collection, and what you have is not a fleet. What you have is the most valuable real-world AI training dataset ever assembled, and Tesla owns all of it. Now here is where it gets interesting. Data alone is useless without the compute to process it. And this is where Tesla made a bet that almost nobody took seriously until recently. They decided to build their own chips, not buy them. Build them. The current generation is called AI4, and it is already in production at scale. The next generation AI5 is nearly taped out, meaning it is about to go into manufacturing. And AI6 is already in design, with a $16.5 billion contract signed with Samsung to produce it at volume. Think about that for a second. $16.5 billion committed to a single chip generation. That is not a research project. That is an infrastructure play at a scale that puts Tesla in the same conversation as companies that have been doing this for decades. And they built Dojo to run it all. Dojo is Tesla's proprietary supercomputing system, designed from the ground up to train neural networks using the camera data from that fleet we just talked about. They have Dojo infrastructure at their Austin headquarters, at co-location sites in Sacramento, and the build-out is ongoing. This is not a data center in the traditional sense. This is a purpose-built training machine tied directly to the real-world inputs coming from millions of moving vehicles. The whole system is vertically integrated in a way that no hyperscaler like Amazon or Microsoft can replicate, because they do not have the cars, and no automaker can replicate, because they do not have the chips or the compute. But then there is the part of this story that most financial media is completely sleeping on, and it is the energy business. Tesla Energy posted 46.7 gigawatt hours of Megapack deployments in 2025. That number sounds technical, so let me translate it. A gigawatt hour of battery storage can power roughly 90,000 American homes for a day. Tesla deployed enough grid-scale battery storage last year to theoretically power somewhere around 4 million homes for a full day, and analysts tracking the company expect that number to climb towards 64 gigawatt hours in 2026. Tesla is not just an energy company in name at this point. They are one of the dominant players in utility-scale battery storage on the planet, building Megapack 3 and new units called Megablock that hit 20 megawatt hours per installation. This business generates real revenue, it is growing fast, and it directly powers the compute and factory infrastructure Tesla needs for everything else. Now bring in the robots. Optimus, Tesla's humanoid robot program, has moved from concept video to pilot production inside actual Tesla factories. The company has converted portions of the Fremont facility and is planning dedicated Optimus production lines in Texas. The stated ambitions, and yes, these are ambitious, are to move from a few thousand units toward hundreds of thousands and eventually millions per year at scale. The reason this matters, beyond the obvious spectacle of a humanoid robot, is the logic underneath it. If Tesla can deploy Optimus inside its own factories to perform assembly tasks, the cost of manufacturing drops, which funds more robots, which builds more factories, which produces more robots. It is an industrial flywheel, and if it works even partially as described, it changes the economics of manufacturing in a way that has nothing to do with what car you drive. Here is the thing that keeps serious industrial analysts up at night. When you line all of this up together, the fleet data, the custom chips, the Dojo supercomputer, the Megapack energy business, and the Optimus robot program, you are not looking at a car company that got distracted. You are looking at a deliberate construction of a full-stack AI industrial platform. Data collection at the edge, proprietary compute for training, energy infrastructure to power it all, and physical robots to act on it in the real world. No other company has all four of these pieces under one roof. The cloud giants have compute and software, but no robots and no real-world physical data. The traditional manufacturers have factories and supply chains, but no training infrastructure. Tesla, for all its chaos and controversy, has quietly assembled the rarest possible combination. Now here is the question worth sitting with for a minute. Is any of this actually going to work on the timelines being discussed? Because the history of this company is littered with ambitious deadlines that came and went. Full self-driving has been perpetually almost ready for nearly a decade. The Cybertruck launched years late and faced early quality issues. Optimus walking around a factory floor is very different from Optimus replacing skilled assembly workers at scale. The gap between a demo and a deployed system in the millions is where a lot of technology goes to die. So what do you think? Is Tesla genuinely building the infrastructure backbone of an AI industrial empire? Or is this the most expensive pivot in automotive history that ends with a reality check? Drop your answer in the comments, because the people watching this channel have been right before when the experts were wrong. What is undeniable is that the capital is real. The energy deployments are real. And the $20 to $25 billion commitment for 2026 is not a press release. It is a line item. Whether the execution matches the ambition is the story of the next 3 to 5 years. And it is going to be one of the most consequential industrial narratives of this decade, regardless of how it ends. If you want to stay ahead of where this is all going, not just for Tesla but for every company in the crosshairs of this shift, this channel covers the mechanics behind the headlines before the mainstream catches up. Subscribe so you are not the last one to see it coming.